Okay, so today we're starting with databases, and something bizarre is happening to my screen there as we look at it. But let's continue on for the moment and see if it makes it any easier. So, what is happening there? Maybe we just move on this way. All right. So almost everything companies, organizations store is kept on a database. Did you realize that? Almost everything companies, organizations store is kept on a database. Did you? What is a database? Who's down there? Harry, is it? Harry, what's a database? To store something, yes, but it's so much more than that. A database is an electronic system used to store, retrieve, and manipulate data. And the really good thing about a database is you can do this quickly and efficiently. And you know, it's in the old days you used to have filing cabinets, and we still have filing cabinets here in the school where you used to organize stuff into the different kind of compartments in that filing cabinet. Now a database is an electronic version of that where you can store, retrieve, and manipulate data. Databases are useful for lots of reasons. So the reasons that they're useful: they're a place to store large amounts of data. Like, you can store huge amounts of data in databases. Look at your online, like even before we come back to the school database here, look at your online flight. If you went to book a flight there with Ryanair or whatever, the amount of databases they have, one for arrivals, one for destination, like in that database, they have loads of things called tables. And these tables are all related, which is going to make up a relational database we'll talk about in a while. But they're all connected. Things like the arrivals, the places you go into, the destinations, where you're leaving from, the times of the flights, and the cost. All of these are different things all linked together. So databases can store large amounts of data. They can provide a structure for that data. So what we mean by a structure is that you're able to understand what's going on in an efficient and, it's in an efficient manner. It's laid out in a way that you're able to, it could be in alphabetical order. You can sort it. You can just structure it in a way that is easy for you, the user, to make sense of it. You can provide a single source of truth. So, in the school, everybody in the school, instead of having the data all over the place for everyone, all of the data is in a single place. It's all aggregated together or put together in a single place and kept together in a single place. And that's what's referred to as a single source of truth, where all of the data can be accessed in one place. It's all kept together in one place. And it's concurrent, which means that lots of us can access the data at the same time. So Mr. Rabbit can access it at the same time as Martina. And before GDPR came in, teachers could access that data too, and all at the same time. And that's what concurrency is. Now, lads, these are a lot of exam terms here that could come up in your Leaving Cert exam. So, just remember this. The word concurrency there. If you're asked to explain that in terms of databases, it's where lots of people can access data at the same time. What is a single source of truth? It's where all the data is kept in one place. So watch out for them. And they can provide us with a common backend for lots of different applications. So when we're talking about the backend, the front end as a user is what you interact with. But the backend is where all the information is kept. Does that make sense? And when you're interacting in the front end and the back end, full stack development there. So, crucially, databases allow us to model a mini world where we can define lots of specific rules. For example, every student must have exactly one email address. What would be the problems there, Lee, if you had two students with the same email address? Sorry? No, they have the same email. Yeah, well, I think you're hitting a bit of it there, but I suppose the main problem is, what if you wanted to send, like one student was in 5th year and another student was in 1st year, and the 1st year student was getting bullied or something, and the 5th year student, so it was fine, nothing was happening to them, and you wanted to, keep something confidential, and you wanted to talk to a student in the 1st year or whatever, and then you're bringing up both of the students' data and all that, or you might email both of them at the same time, and but just basically confidentiality and privacy. That's one big thing about why a student would want only one email. Now, some of you are clicking there on mice, like, you with me here? Yeah, come on, hand off the mouse there, please. Yeah, or left hand, or who was it there? I heard someone. So, a student number must be unique, and this is what we'll see in a while, what will identify each student. So, let's say in this room, Ben, you might be 0001. There can never be another 0001. That's you, you're 0001, and no one else can have that. There could be 40 Ben Englishes in this school, but the next one might be 0020. The next one might be 0000. Next one might be 0100. Next one could be 0105. Whatever the case may be. But you will have 0001 and that's it. Brian, you could be 0002. And again, no one else can have it. And why do I 4 digits? Because I'm imagining possibly in some time down the line there could be 1,000 students in this school. So maybe 4 digits should hopefully be enough. I doubt we'll ever have 10,000 students in this school, but you could have potentially 1,000. So I keep going around. Brendan, you'd be the 3, 0003. Luke, you'd be the 4, the 5, the 6, and but you would have unique ID, and that was what would indicate you. So if there was 5 Luke O'Briens, you'd all have different IDs. And a student cannot be issued a diploma without achieving 180 credits. So, task for you here very quickly. 5 minutes to compile a list of databases which store personal information about you and the kinds of information they might store. See you shortly.